All right, so now we move on to lesson 2 of relations and functions, and it's dealing with intercepts and slopes. So what we're going to do is we're going to break this lesson into 2 sections. The first part is to review coordinate labeling and determine x, y intercepts. And the second part is going to be determining the slope for slope-intercept form here. So let's move on to section 1 here, which would be coordinate review and intercepts. So when we look at coordinate review and intercepts, first of all, what we're going to do is we're going to establish if I take a point and I want to put it on the coordinate grid or the Cartesian plane, what does it look like? And then specifically, what do those points have for x and y's? Are they positive? Are they negative? So let's actually take a look here. We're going to take each of these A, B, C, D, E, F points, and we're going to apply them directly onto the Cartesian plane here, and then use that as a way to determine, well, when are our x values positive, when are they negative, for what points? So let's start off with point A, which I'm going to do every one of these points in, let's say, blue. So point A is located at -2, 3. And remember that every point is in an ordered pair in terms of x and y. So when we plot this on the graph, it's going to be -2 for x, and then +3 for y, which would be right here. So we can put it on the graph, label it point A. We then go to B, which is 2 for x, 0 for y, which is here, and so we can label B here. We go to C, which is -3 and -4, which would put us down here. We then go to 0x and -3y, which puts us here for D. And then we have E, which is 4 and 4, or 4 positive for x, 4 positive for y. That's up here, which becomes point E. And then finally, we have F, which is +3x, -1y, which would put us right here, and this would be point F. Now, if we were to look at any of these points here, we've now mapped points, but now we want to say, if I'm looking at quadrant 1, 2, 3, or 4, where quadrant 1 always starts in the top right, and we rotate counterclockwise around till we reach the 4th quadrant, we go 1, 2, 3, and 4 in a counterclockwise rotation. Now let's determine what quadrants have what type of x and y's. So if I go below, all points in quadrant 1 have, well, in quadrant 1 we see that it's positive in the x and positive in the y. So that's what we're going to place here, positive in the x, positive in the y. In quadrant 2, or this quadrant here to the left, we have negative x values and positive y values. So we're going to have negative x, positive y. In quadrant 3, the one just below it, we see that they're both negative. So we're going to put negative x, negative y. And then in quadrant 4, or our bottom right quadrant on the Cartesian plane, we have positive x values, negative y. So positive x and negative y. All points on the x-axis have a y value equal to 0. A y value of 0. Now, why is that? Because when we're on the x-axis, if I highlight the x-axis here, have I vertically displaced at all? No, I have not gone up or down at all. I'm directly right on the line of the x-axis, meaning I haven't vertically displaced, so they have a y value of 0. And similarly, if I look at all points on the y-axis, well, what value would they have? All of their x values here would be equal to 0 because we haven't displaced left or right at all. We're not left and we're not right, so we can't say that there is any x value other than an x value of 0 along that line, an x value of 0. All right, perfect. So now that we've determined quadrants where x and y are positive or negative, and we know that on the axes, specifically x-axis, y values are 0, and y-axis, the x values are 0, let's work on to our next page here. So we're going to take 2 applied examples here and then say, okay, well, if I have graph 1 and 2, let's see what we have for x-intercepts and y-intercepts. So starting with graph 1, the x-intercept of this graph occurs when it crosses the x-axis, which would be right here. So what do we have? We have 1, 2, 3, 4, and 5 for the x value, and 5 is where it crosses the line. So we're going to put our x-intercept is 5, or if we wanted to put it in the coordinate notation, or more importantly, the ordered pair, we would say that this is 5 for x, 0 for y, because remember, any point that's on the x-axis is going to be 0 for y. The y-intercept would be down here where it crosses the y-axis, and if we count the points here, we should realize that's 5 here. So, and I should say -5 because we're down 5 units. So when I go over to my y-intercept here, I'm going to put that this is equal to -5, or as a point of an ordered pair point, we have 0 because it's on the y-axis and -5 for y. There we go. Now, let's look at graph number 2 here and see if we have an x-intercept or a y-intercept. Well, we definitely have an x-intercept because we see it crosses this horizontal axis. Where does it cross? This looks to be at -2. So when we go to our x-intercept for graph 2, it's going to be -2 or -2 and 0 for y. The y-intercept, well, we look at this and it's a direct vertical line. Would we ever cross the y-axis? No. So in this case, we're going to say that our y-intercept, there is just none. All right, so this is where you'll want to check your understanding of this lesson just by making sure, do you know what x-intercepts are, y-intercepts? Can you determine if I give you a point on a line, can you tell me what that is in terms of an ordered pair? And then finally, what quadrants does it run through? So you'll need to determine those details for any given graph. All right, now if we move on to slopes and our slopes from a graph, which is our part B of this lesson, we're going to deal with specifically what constitutes slope. And I mean, we've talked about this in the previous lessons, but we just want to get it really specific and really interpret what's happening with slope. So finding a slope from a graph, well, slope is always denoted by m, and it's our vertical change over our horizontal change, or the rise over run. Now, something I want you to add to your notes here is when you see this triangle symbol here, what is that symbolizing? Well, in science, you would have learned this is change, or potentially even any math course that you would have taken. Change is always denoted by this triangle here, representing a change in that variable, or a change in y over a change in x. So if we look at the couple examples we have off to the side here, well, we would say that our first example is a negative slope because we have to go from left to right. We decrease by a certain amount of units and go right by a certain amount of units, meaning this is a negative slope. Versus if I go from left to right and I'm increasing by units and over by units, that means we have a positive slope for an example like this. Or a positive change in y over a positive change in x for here. And the example below directly runs through that. It says if I give you 2 points on a graph and we realize, okay, if we go left to right, we go up 4 units over 6 units, we would get a rise over run, rise of 4 units, or change in y of 4, change in x of 6, which reduces to 2/3, and we could say that that's our rise over run. Now, let's actually look at some characteristics of slopes. So oblique lines, or lines with a positive or negative slope here, well, that's what goes in our box. They have a positive and negative slope. Okay, horizontal lines. So if we look at this example here, a horizontal line, well, they have a rise of, in this example, there is no increase between those 2 points on the graph. So if I was to draw a point here and a point here, going between those points, there's no rise. So we actually say the rise is 0. The run, well, the run is determined by how many x units we move between 2 different points. So it's our x, and therefore the slope is rise, which is 0, over run, which is our change in x. Therefore, the slope is equal to 0. Okay, vertical lines. We're looking here. So they have a rise of, well, if I consider this point and this point, it would be a change in y, or a certain amount of y units. So a change in y, and I should even throw a change in x there. A run, well, in a vertical line, do we move left or right? No, because if I take 2 points here, I'm not going left or right to get to those. I'm strictly moving up or down. So I get 0 run, and therefore the slope is change in y over change in x, which is 0, which results in an undefined slope. So anytime we have a horizontal line, it's a 0 slope. Anytime we have a vertical line, it's an undefined slope. Why is it undefined? We cannot divide by 0. That's your indicator that it's undefined. Now let's look on to example 1 here, where we actually have to determine the slopes of certain lines. So let's consider A to B, or our first example here. Well, A to B, it's increasing from left to right, so we should expect a positive slope, and now we just have to count up how many it goes up versus over, or the change in y over the change in x. So if I go up by a certain amount of units and over by a certain amount of units, it looks like we go up 1, 2, 3, 4, 5, 6, 7 units upwards, and then 3 units over, meaning the slope is 7 over 3 for AB. If I look at C and D, if we look at this from a point of view of left to right, it's decreasing. Now we want to determine, if I draw my lines over and down, this means I would go down by 2 units, or a negative 2 units, and over by 1, 2, 3, 4, 5, 6 units, meaning my slope for that would be equal to negative 2 over 6, or the change in y over the change in horizontal distance, which reduces down to negative 1/3. E to F, we can clearly see it's a horizontal line. Right away we would predict, oh, well, that's going to be a 0 slope, but let's show why. Our change in y, there is no change in vertical distance, so it is equal to 0 over, if we go from E to F, or endpoint of E to F, that is a difference of 4 units. And so 0 over 4 is just strictly equal to 0. And then finally, G and H, we actually covered this, a vertical line. It has a certain amount of y units changed, and in particular, the change between G and H is actually 1, 2, 3, 4, 5 units. So we would say a change in y of 5 over, what we notice about these lines is that between any 2 points on this line, they don't shift left or right. So it would be 0, or this graph would be an undefined slope. All right, now example 2, draw the line that passes through the given point with the given slope, and then label each line with the letter. So what we're going to do here is we're going to say, if they give us a point, we're originally going to take this point, map it, and then use the slope to create another point that would make the line. So right away, I'm going to try and use a couple different colors here to represent these. So negative 7 over 2, or maybe just even labeling, negative 7 for x, negative 2 for y. So that's going to put us right here. And now, if I have a positive slope of 5 over 4, that means I rise by 1, 2, 3, 4, 5, and I go over 4 units, which would put me here, and I'd put another solid dot here, and now I would connect those 2 points, and then call this graph A. Now, if I move on to the next example, passing through B, or B graph is passing through negative 5, 6 with a slope of negative 2, what we're going to do is we're going to go to negative 5 and positive 6, which would put us right here. And then what we need to do is say, okay, the slope is negative 2, and another way to conceptualize negative 2 as a slope is negative 2 over 1, or 2 down and 1 right. So now, when we go back to the graph, we go 1, 2, and 1 over. There's our graph there. And I mean, we could create another point just below as well, and then connect these points here. So that's what our graph would look like, and we would call this graph B. Now, a line passing through 5, 4 with a slope of 0, slopes of 0 actually are horizontal, and we know this from the previous page and even the previous example that we were working with. So what we're going to do is we're going to go to 5, 4, or positive 5x, 4 for the y, and then we're going to determine a slope of 0. Well, slopes of 0 we know are just horizontal directly across, and we're going to call this C. And then finally, passing through point 3, negative 2. Well, 3 and negative 2 is here, and if it has an undefined slope, what was the characteristic of an undefined slope? It means that it is a vertical line. So right at this point, we can just draw a vertical line up, and we can call this graph D. So it passes through those given points, and we just draw the line. All right, example 3, arrange these from the slopes with the flattest to the steepest slopes in these cases. So arrange the slopes from flattest to steepest. I'm going to pull up a grid. So I'm going to pull up just some random grid here, and what we're going to do is we're going to map out example A, and then I will allow you to do B on your own. So our slopes for this, I'm going to zoom out and go back. We have 1, 1/2, 3/4, and 2/3. So I'm going to write them out here. We have 1, 1/2, and then I believe it was 3 over 2, but let's just double check. No, 3 over 4 and 2/3. 3 over 4 and 2/3. Okay, and they want us to determine the flattest versus steepest slope. So, and then we're going to arrange them in that order. So what I would do is right away, I would draw these just in any space. What does a slope of 1 mean? It's actually 1 over 1, which means, let's say I plot the first point here. Then I rise 1 over 1, rise 1 over 1. So my points would be here, and I could draw a line through these like the following. Now I go to a slope of 1/2. That means, let's say I choose this as my first point, then I'm going to go up 1 and over 2, up 1 and over 2. So here are my bolded points. I connect the line as following. Now 3/4, let's say I choose my point to be here. I rise by 3 units, 1, 2, 3, and over 4 units. That would place me here. And I can connect those dots as following. And then lastly, suppose I have 2/3. I'm going to choose this as my point. It means I rise 2, 1, 2, 3 over, and here is my graph there. And I'll draw that just slightly better just so you can make sure we have a better line there. Okay, so now they say we need to determine the flattest to the steepest. Well, right away, we actually know that this is our steepest, so I'm going to label it 4. It goes right at the end. 1 over 1 gave us our steepest curve. What was the next steepest curve? It was definitely the 3/4, which was here. Our next steepest pass there was our 2/3, so this is going to become our second option. And then finally, our flattest was 1/2. Now, what I want you to determine from here, what I want you to realize in terms of this ordering, is that when we write all these as a decimal, well, we have 1, 0.5, 3/4 is 0.75, and then 2/3 is 0.66 repeating. What we noticed is that the flattest curves had the lowest value slope, and the steepest curves had the highest value. So if I put the orderings in pairings with their actual, like I know we see them on the graph here, but if I wanted to actually write them with their numbers, we would say the flattest curve was 0.5. Then it went up to 6.6, which is here. This was our next steepest, and then finally our steepest graph was 1. So the larger the value for the slope, the steeper the graph. But if it starts getting really fractional, we know that this slope is going to be very flat or very like almost horizontal or approaching horizontal. All right, now we've solved example A, but I want you to try this one for your own, example B. So this one will be for you to try. Example 4, determine the slope of a line with an x-intercept of 3 and a y-intercept of 5. So right away, if they tell us intercepts, what we're going to do is put them as a coordinate. An x-intercept is always 3 and then 0 for the y variable. A y-intercept is the opposite. It's 0 for x and 5 or whatever value for the y. Now what we're going to do is we're going to plot these points because we know they're an x and y. So if I go 3 positive x and 0 for y, I would be here. And if I go up to 5 units for y, I would be here. And the line that would connect these 2 points would be here. Okay, we've created the line that crosses through an x-intercept of 3 and a y-intercept of 5. All right, so the next thing for you to do would be to check your understanding. You need to practice these things, especially just being really familiar with when do I have a flat curve, when do I have a steep curve, what does it mean to plot points on a graph and then connect them? What does it mean to draw a line that's passing through a given point with a slope? Those are all things you need to practice.